See, this is the given question. So, a block of mass m is slowly slid through a distance of d on a rough horizontal surface of coefficient of friction mu by applying a force at an angle of alpha with respect to horizontal. So, find the work done by the force if applied force is minimum. That is the question. Okay, ma? Let us try to draw the diagram of this one. Ma? So, this is a body of mass m. So, it should be taken through a distance of d. I want to move this one by a distance of d on a rough horizontal surface whose coefficient of friction is mu by applying a force of F at an angle of alpha with respect to horizontal. Okay. Then you are supposed to calculate what is the work done by this force. That is the question. And the force is minimum force. Okay, now first of all here we should concentrate about slowly slid. What is meant by slowly slid? Slowly slid means? Slowly slid ante meaning cheppandi. Moved slowly, it means it is moved with some uniform slow velocity. It means this body is not accelerated. Body is not accelerated, it is moved with a constant velocity, that's it, very small velocity. So therefore what I can say velocity is a constant number. Velocity is constant means acceleration. Acceleration is 0 means net force. Net force is also 0. Net force is 0 means what? All forces are balanced. All forces are balanced. This is what the information which I will get now. It means all the forces which are acting on this mass m, they are balanced. It means all the forces along x-axis are also balanced. All the forces along y-axis are also balanced. Clear now? But here this force, it is not along x-axis, it is not along y-axis. No? So first split this one into two components. Clear? So this is applied force F. We are splitting this one into two components. This is angle alpha, this is F cos alpha, and this is F sin alpha. Are you able to understand now? Then first of all what you are supposed to do, first of all draw the free body diagram. Okay, ma? So if I draw the free body diagram of this mass, now can you say on this mass how many forces are acting? Cheppandi. First of all you write F cos alpha in this direction. F sin alpha is in which direction? F sin alpha is in upwards direction. Clear no ma? Then some other forces. Weight of this body mg will be acting downwards no ma? Clear no? And normal reaction will be acting in which direction? Normal reaction will be acting in upwards direction. Body is trying to slide in this direction. No? So friction will act in which direction? Friction will act in this direction. Can I say friction has already reached the maximum value? I can say friction has already reached the maximum value. Why? Because it is already in movement. You know? When it is already in movement, it means the friction is already maximum value. So therefore I will write a limiting friction, Fn. Limiting friction means maximum static friction. Are you able to understand? So these are the different forces which are acting. Still any other forces ma? Friction, normal reaction, weight, F cos, that's all. These are the forces. Clear? Now if you take along x-axis. Along x-axis what are the forces which are present? So one is F cos alpha, another one is Fl. So definitely they should be equal number. So therefore I will write F cos alpha and Fl, they are equal. So what is the equation for Fl? Mu s into n. So mu s into n. Clear number? Let it be my first equation. Clear? Then I will write equation along y-axis. Clear? So where shall I write? I will write here only. Equation along y-axis. Clear? Along y-axis how many forces are there? Chapal Twarga. N plus F sin alpha should be balancing the weight of the body mg. That's all. So therefore from this you derive the normal reaction. So normal reaction is how much? Mg minus F sin alpha. So take this normal reaction, substitute here. If I substitute here what I will get? So F cos alpha is equals to mu s into normal reaction. Instead of normal reaction I will write Mg minus F sin alpha. Clear number? So therefore F cos alpha plus mu s F sin alpha is equal to mu s into mg. So from this you calculate F value. So F value is cos alpha plus mu s sin alpha is equals to mu into mg. Clear number? So therefore what is the applied force ma? Applied force is mu mg divided by cos alpha plus mu s sin alpha. Clear number? So therefore first of all I have calculated the applied force. Why I have calculated applied force ma? Then only I can calculate work done. Work done only, no, he is asking. Without force, how can I calculate work done? Clear? Now what is the work done? W is equal to Fs cos alpha. That's all, nama? Work done equation. Force is in this direction, displacement is in this direction, angle is alpha. So work done Fs cos theta. Theta value is alpha here, no? Cos alpha. So therefore work done is equals to, force is mu mg, displacement is d divided by cos alpha plus mu s sin alpha multiplied by again cos alpha. Clear number? So you can leave up to here, or if you want to supply, you can further simplify this one. So this cos alpha, if it goes to the numerator, it will become cos alpha by cos alpha. No? Cos alpha by cos alpha will become 1. So mu s sin alpha by cos alpha, it will become tan alpha. So mu s tan alpha. So you can write like that also. If you want, you can write, or you leave up to that. Understood, Amma? That's it. See this question, ma. So this is a table on which a chain is hanging, ma. Clear, no? Total length of the chain is L and total mass of the chain is M. So by applying some force, I want to pull this remaining hanging part of the chain onto the table. Clear, no? I want to pull the hanging part of the chain onto the table. Then in that condition, how much amount of work I have to do? That is what I am supposed to calculate. Are you able to understand, ma? And how much part of the chain is hanging? 1/3 part of the chain is hanging. So I want to calculate how much work I have to do to pull this hanging chain onto the table. Are you able to understand? So this problem we can do in two methods. Now by taking center of mass concept also we can do, or just by using the equation of work done for variable force also we can do. Clear, no? We will try to do in both the methods. So first method, clear, no? So by using center of mass frame, or by using the concept of center of mass. Are you able to understand? See, ma, here first of all let us derive a general relation, then we will substitute the data which is given in the question. Okay, general relation first of all we will derive. So listen very carefully. So let us consider L by nth part of the chain is hanging. So here n value is 3, no? 1/3 is hanging. So first of all we are deriving a general relation. So let us consider L by nth part of the chain is hanging. Clear? Now see. When I start pulling this chain upwards, initially I have to apply large force. No? When I start pulling the chain onto the table, first of all I should apply more force. Why? Because initially the length of the chain will be greater. But once I start pulling some chain, weight of the hanging chain reduces. No? Weight of the hanging chain reduces. So the force which I will apply also will reduce. So force which I am applying, is it a variable force or is it a constant force? Definitely variable force. No? అర్థమవుతుంది ఏం చెప్తున్నాను? ముందు చైన్ ఎక్కువగా హ్యాంగ్ అవుతుంది. సో మీరు ముందు దాన్ని లాగాలంటే ఎక్కువ ఫోర్స్ని అప్లై చేయాలి. సగం లాగేసిన తర్వాత ఇప్పుడు హ్యాంగింగ్ చైన్ కొంచెమే ఉంటుంది కదా, వెయిట్ ఆఫ్ హ్యాంగింగ్ చైన్ ఆల్సో విల్ బి లెస్సర్. సో యూ నీడ్ టు అప్లై ఓన్లీ లెస్ ఫోర్స్. Okay, and when you completely pull the total chain onto the table, the force which you are applying almost 0. So force is a variable. Are you able to understand? But if I want to solve the problem by center of mass frame reference, I can consider force to be a constant. Ela sigma. So L by nth part of the chain, no, where center of mass will be present? Center of mass will be present exactly at the center of this hanging part of the chain. No? So then what is this distance? This distance is L by 2n, no? Are you able to understand? For this hanging part of the chain, center of mass is present at its center, because this is a symmetrical body, no? For symmetrical bodies, center of mass will be present at the geometrical center. Are you able to understand? So what is the position of center of mass? L by 2m. So center of mass means what, ma? Total mass of this hanging chain, I can assume as if it is concentrated at this point. Ade kada center of mass ante. Center of mass means it is that position where I can assume total mass of the body is supposed to be concentrated at that point. Ante total mass akkade undemo anipistundi anamata. For example, if you take this mass, if you take this pen, I can balance this pen on my finger at some point, no? So it means that is that point where I can assume total mass is concentrated. That is the point of center of mass. Okay. So for this remaining part of the chain also, at its center only its center of mass will be present, no? So total mass of the chain is concentrated here. Okay. What about the remaining mass of the chain? We can assume that remaining mass is not present there. Total mass is concentrated here only. So if I pull that part of the chain onto the table, automatically total chain will come onto the table. Are you able to understand, ma? Ante ela assume cheskuntanu deenni nenu I will assume this to be like this. Clear, no, ma? So I will assume this is the part which is present on the table. Okay, ma? And hanging part of the chain I can assume like this, where total mass is concentrated here only at a distance of L by 2n. అర్థమవుతుంది కదా? So now this hanging part of the chain, it is behaving like what body? It is behaving like a point mass. Are you able to understand, ma? It is behaving like a point mass. Why it is behaving like a point mass? Because we have taken the concept of center of mass. Now here also there is no mass, here also there is no mass. Mass is totally present here. That is the concept of center of mass. Now if I apply force on this mass and pull this center of mass onto the table, then automatically total chain will come onto the table. Are you able to understand? Because this is a point mass, I need to apply constant force. No? Here there is no concept of variable force. ఇక్కడ వేరియబుల్స్ ఫోర్స్ అప్లై చేయాల్సిన అవసరము లేదు. అర్థమవుతుంది కదా? బికాస్ ఐఎమ్ లిఫ్టింగ్ జస్ట్ ఏ పాయింట్ మాస్ ఆన్ టు ద టేబుల్, అంటే ఒక రాయిని పైకి లేపినట్లు అనమాట. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో జస్ట్ ఇఫ్ ఐ మూవ్ దిస్ బాడీ ఆన్ టు ద టేబుల్ ఆర్ దిస్ పాయింట్ మాస్ ఆన్ టు ద టేబుల్, టోటల్ చైన్ విల్ కమ్ ఆన్ టు ద టేబుల్. ఫైన్ నమ్మా? ఓకే. నౌ ద క్వశ్చన్ ఈస్, వాట్ ఈస్ ద మాస్ ఆఫ్ దిస్ సెంటర్ ఆఫ్ మాస్? హౌ మచ్ మాస్ ఈస్ ప్రెసెంట్ హియర్? కెన్ యూ సీ? Or what is the mass of the hanging part of the chain? How can I calculate? So mass of hanging part. How can I calculate, ma? So can I calculate it as L by N divided by N multiplied by total mass? I can use this relation. No? Okay, ma? What is L by N? Mass of the hanging part. Sorry, length of the hanging part. What is L? Total length. So hanging part divided by total length, it will give fraction of length, no? Fraction multiplied by total mass, fractional mass. Are you able to understand? So L and L, if they get cancelled, then M by N mass is hanging. So total mass lo enta mass hang avutundi ma, M by nth mass of the chain is hanging. Remaining mass is present on the table. Are you able to understand, ma? Remaining mass M minus M by N, it is present on the table, but hanging mass is how much? Hanging mass is M by N. So therefore what will be its weight, ma? Weight is how much? Weight mg, no? So M by N multiplied by G. So this is the weight of the hanging part of the chain. Okay? It means this point mass, it has how much mass? It has this much amount of mass. That is the meaning of this one, no? Okay. Now I will apply force on this mass and I will lift this mass onto the table. So what is the equation for work done? Work done is equal to Fs cos theta. This is the equation for work done, no? Why I am taking this equation? Because I am lifting point mass, no? So work done, force applied will be constant. If force applied is a constant, then this is the equation which I have to use, no? W is equal to Fs cos theta. Force, how much force I have to apply to lift this one? And the force apply chayali. Force equal to weight of the hanging part. Weight of the hanging part is downwards, no? I have to apply equal and opposite force in upwards direction. Then it will start rising slowly in upwards direction. So how much force I have to apply? Mg by N, this much amount of force I have to apply, Mg by N. So Mg divided by N, this much force I have to apply in upwards direction. And displacement. So this point mass, I should displace by how much distance? L by 2n distance, that's all. So L divided by 2n distance, cos theta. Force I am applying in which direction? Upwards direction. Displacement is also in which direction? Upwards direction. So cos is 0. Both are in same direction. So what is the final answer I got? So mgl divided by 2n square. So this is a very, very, very important relation. Clear, nama? So to pull nth part of the chain onto the table, this much amount of work you are supposed to do. Fine. Now what is n value here? N value is nothing but 3, no? So substitute 3 there, then that is my required answer. Clear? So therefore to pull 1/3 chain onto the table, how much work I have to do, ma? So mgl divided by 2 into 3 square. 3 square is 9, 9 2s are 18. So mgl divided by 18 joules of work I have to do. Clear? If mass is taken in kgs and length is taken in meters, then joules is the unit of work done. Fine, ma? That's it. And this is the most important equation which you should remember. mgl divided by 2n square. This much amount of work I have to do to pull nth part of hanging chain onto the table. Have you understood, ma? Based on which concept we have done? That's all. Total L by N is hanging, but center of mass is present at L by 2N. Clear, no? So this is behaving like a point mass. So this point mass, if I take onto the table, definitely total chain will come onto the table. So previously we have done by center of mass frame, no, ma? Now we are doing by using a general method of solving the problem. Clear, ma? Now see, ma? So to pull this chain onto the table, definitely I have to apply force in this direction, no, ma? I have to apply force in upward direction. And this force, is it a constant or is it a variable? Definitely variable force. Because initially length of the chain is greater, its weight is greater, the force which I have to apply is also greater. But once I start pulling this one, I have to apply less and less force, no, ma? So definitely force is a variable. If force is a variable, then what is the equation of work done? W is equal to integration of F ds cos theta. This is the equation of work done. Limits are applied from S1 to S2. Clear? Now initially, how much amount of force I have to apply? Initially, how much amount of force I have to apply? Equal to nothing but weight of the hanging part of the chain. So therefore, what I will do, I will assume let and the length is variable. No? Length is definitely variable. No? Because as I start pulling the chain, length of the chain varies. Clear? So let us assume the length of the hanging part of the chain is L. Okay. So therefore, force which I have to apply is how much shall I write? It is small l divided by capital L multiplied by weight of the total chain is mg. Can I write like this? Weight of the total chain mg. So if L length of the chain is hanging, the how much fraction of chain is hanging? Small l by capital L.
So total length of the chain is?
Total length of the chain. Huh? That we will do later. First we will derive a general relation. Then we will substitute L value. Are you able to understand? So therefore, length of the hanging part of the chain, let it be L. Okay, ma? So see, see ma, here total length of the chain is L, ma? Hanging the part of chain is how much? Small. So small l by capital L, fraction of length. How much fraction is hanging? Fraction multiplied by total weight of the chain, fractional weight which is hanging, or fractional weight of the chain which is hanging. So in upwards direction also, you have to apply this much amount of force only. No? What is the weight of the hanging chain? Same force you have to apply in opposite direction. Then the chain starts lifting upwards with uniform velocity. Are you able to understand? Okay. So this is the force. Now let us substitute in this equation. So W is equal to integration of F is mg small l divided by capital L multiplied by dl multiplied by cos 0. Why I am writing cos 0? Because force is applied in upward direction. Displacement is also in upward direction. So angle between them is 0. Now what are the limits of integration? So first I have to pull first 0 length of the chain, and I have to pull up to which level? I have to pull up to L by N length of the chain. That's all, no? First I will start from 0. How much length I have to pull? Total hanging part of the chain. Hanging part of the chain L by N, no? So L by Nth part of the chain I have to pull onto the table. Are you able to understand? Now just do the calculation. So therefore mg by capital L, they are constant. So mg by capital L, you take them outside. So integration of small l dl multiplied by cos 0 value is 1. So limits are from 0 to L by N. Clear, no? So mg by L multiplied by integration of L is how much? L square divided by 2. Limits are from 0 to L by N. Clear, no? So mg by L multiplied by 2L. This 2 you can take here. So in L square you can substitute L by N whole square minus 0. Clear, no? So therefore mg divided by 2L multiplied by L square divided by N square. So L and 1L will get cancelled. So therefore mgl divided by 2n square. So this was the same answer which we got previously. No? Clear, no? That's all. So in this method also you can do the calculation. So this calculation was done without center of mass concept. Okay. In center of mass concept, what is the advantage? We need not use integrations. Clear, no? So there we are considering mass of the body is a constant, because center of mass is a point mass. No? So just if you lift the center of mass and keep on the table, total chain will come onto the table. But here we are using the general method of solving the problem. Fine. That's very simple. Okay.
Sir,
Hanging length small l. Small l only, for small l only we are taking the limits. First I have to pull 0. I will start from 0. Then I will pull up to L by L. So what is small l here? Small l varies from 0 to L by L. L is a variable here. Sima, to do integration, definitely you require a variable, no? And what is the variable here? Hanging part of the chain is the variable. Clear? So you will write that one first in terms of variable, then you apply the limits. First you will start from 0, then you will pull how much part of the chain, ma? L by N part of the chain. And here what is N value? 3. So again substitute 3 here. Again you will get mgl by 18. That's it. So these are the rules of methods of solving the problem with integration. Clear, no? Integration to meeru ila cheyali. So you should have an idea about friction very perfectly, then you can do this problem. Simple. So here again the same question we are taking. So some part of the chain is hanging from the table, and in between the table on the chain and the ground or this table, there is some friction also, whose coefficient is given by mu. Okay, ma? Now if I start pulling this chain onto the table, friction starts opposing the motion of the table chain, no, ma? For example, if I start pulling this chain in this direction, chain will start moving in this direction, then friction will develop in which direction? Friction will develop in opposite direction, and friction is definitely maximum and it is limiting friction, no, ma? When bodies are already in movement, it means friction has already reached the maximum value. Friction is a variable force, no? When bodies are in movement, it means definitely friction has reached a limiting friction. So chain is moving in this direction, friction is acting in opposite direction. Okay, so this is the direction of friction, but chain is moving in which direction? Chain is moving in this direction. So definitely here I can say friction will do negative work, no? Friction will do negative work. Why friction does negative work? Because chain is moving in one direction, but friction is applying force in opposite direction. Are you able to understand? Okay. And friction is a variable also, no, ma? Friction, is it a variable or not? See, ma. Limiting friction formula, mu s into n, no? What is n? Normal reaction. Here what is the normal reaction? Normal reaction is given by the length of the chain which is present on the table. Clear, no? If mass of the chain which is present on the table, if it changes, normal reaction also will change. So if normal reaction changes, friction also changes. So friction is a constant force or is a variable force? Variable force. Arthamavutunda? Clear, ma? If I start pulling the chain onto the table, length of the chain on the table increases, no, ma? If length of the chain increases, it means mass of the chain on the table also increases. If mass increases, normal reaction also increases. If normal reaction increases, limiting friction also increases. So limiting friction, is it a variable? No, limiting friction is not a variable. So limiting friction is not a constant, it is a variable. So therefore what is the equation for work done? Integration of Fs cos theta, limits are applied from S1 to S2. This is the equation which I have to use now. So therefore W is equal to integration of, force is nothing but limiting friction multiplied by F ds multiplied by ds multiplied by cos 180. Why I am writing 180, you understand, no? Because friction will act in this direction, but body will move in this direction, opposite direction. So this is my equation. Now the question is, how can I calculate FL? Limiting friction, how can I calculate? Limiting friction formula, mu s into normal reaction only, no? Okay. How can I calculate normal reaction? What is the weight of the remaining part of the chain which is falling on the table? Table also will give same amount of normal reaction. Table paina unna chain, table paina enta force apply chestundo, table kuda ante normal reaction istundi. So how can you calculate normal reaction? So let us do one thing. Length of the hanging part of the chain, let it be small m. Length of the hanging part of the chain is small m. Then what is the remaining part of the chain which is present on the table? Capital L minus small m. So because of that capital L minus small l only, normal reaction will be acting. Are you able to understand, ma? So therefore how can I write n value? N value I can write like this. Clear, na, ma? L minus capital L divided by capital L multiplied by capital M multiplied by G. This is how I can write. Okay. Have you understood why I have written like this? Okay. So what is the length of hanging part of the chain? Hanging part of the chain is L minus small l. So L minus small l divided by total length, a fraction of length, fraction which is present on the table. Clear, no? Fraction multiplied by mass, fractional mass. Fractional mass multiplied by G value, fractional weight. Are you able to understand? So this is the normal reaction. Okay. So this much amount of weight of the chain is falling on the table. Then table will give equal amount of normal reaction. So that is how we can calculate the normal reaction. Understood, no? So therefore what is FL value? FL value is mu s into n. N value is L minus L divided by L multiplied by mg. Clear, no? So FL value I calculated. Now just substitute in this equation, that is my answer. Fine. Now let us do the calculation. So work done is equals to integration of FL value is how much, ma? So mu s mg multiplied by n minus L divided by L multiplied by ds or dl I can write. dl multiplied by cos 180 value is minus 1. Okay, that's all, no? Now what are the limits of integration, ma? See, ma. So if I travel in this direction, first of all I will start from here and I should pull this much amount of chain onto the table. Clear, now? So here the length of the chain still which I have to pull is how how much it is? L by N. Clear number? And I have to pull up to which length? I have to pull up to L length. So like this also you can write the limits. Are you able to understand? Ma? I should start from L by N and I should end up to L. Clear? No? Because I am pulling in this direction. No? Ma? I will start from L by N. L by N part is hanging. No? And I should end up to where? I should end up to L. So limits of integration are L by N to L. From here to here I have to pull the chain onto the table. Friction is acting up to this much length only. No? Okay. Now do the calculation. So what are the terms which are constant? Ma? Mu is a constant, M is a constant, G is a constant, capital L is a constant. So take them out of integration. So therefore mu capital Mg divided by L minus this minus I am taking here, integration from L by N to L, and what are the terms which are left with? Ma? L minus L multiplied by dl. Okay. Now you know how to integrate. No? Clear? No? Now do the integration. So W is equals to minus mu capital Mg divided by L. Integrate. Okay, ma? So now you are supposed to substitute the limits now here. So W is equals to minus mu capital Mg divided by L multiplied by, first of all you substitute the upper limit, ma? L into L, L square minus capital L square divided by 2 minus of, now you substitute the lower limit. What is the lower limit? L into L by N minus of L by N whole square divided by 2. Clear number? Then you do this total calculation, that is your answer. Okay. So what was the mistake we have done? Integration of small l dl, L square by 2, small l square by 2, no? By mistake we have written a capital L there. So therefore I got a mistake. So first of all you substitute total capital L, ma? So instead of small l, capital L into L, L square. Then you substitute L by N. So total doing minus, then you substitute instead of small n, L by N. And here also L by N whole square. Okay? Okay, ma? So then you substitute N is equal to 3, ma? Then this is the final answer which you should get. Minus 2 mu mgl divided by 9. Okay?